Okay, so in this video we will see the step how we can use the fast Fourier transform to calculate the DFT. Okay, for this step we will use the decimation in frequency. First step is to draw lines depending on number of sample. For example, if we have n, the number of sample equals to 4, we will draw 4 lines here. 1, 2, 3, 4. Okay. And next is we determine the number of stages. Okay. So in this case, when we have number of sample equals to 4, 2 to the power of stage where m will be equals to 2. Okay, so this is the first stage. We will divide this stage with 1 minus. Okay. Next is we do the label. For the left side will always be the discrete signal, and for the right side will always label as the discrete Fourier transform, DFT. Okay. Next is you label the I equals to 1, I equals to 2. Okay. Next step is we label the discrete signal and the discrete Fourier transform signal, DFT. Okay. For the DIF, we arrange in ascending order of binary value at the discrete signal side. Okay, so 0, 0, 0, 1, 1, 0, 1, 1, and this one is the full value of the discrete signal. Okay, as I mentioned previously. So we have 0, 0, 1, 0, 0, 1, and 1, 1. And then this binary number is transformed into the decimal number. So 0, 0 is 0, 0, 1 is 1, 1, 0 is 2, and 1, 1 is x3. Okay. The same for the XDFT. We transform the binary number into the decimal value. Okay. This is the second step. Okay, next step is we find the pair. Okay, we find the pair. So for finding the pair, the important value is the k. Okay, so at the DIF we will use k equals to 2 to the power of stages, number of stages here, 2 to the power of 2, which is 4. And then for the stage 2, we will reduce the value of stages into 1. So 2 to the power of 1, we will have 2. Okay. So for the point, for the first point where we have x0, so n equals to 0, the pair is 0 plus 4 divided by 2. So we'll get the pair of x0 is x2. The same step when we have n equals to 1, so 1 plus 4 over 2, we will have 3. x1 will be paired with x3. For the second stage, okay, we have k equals to 2. The first point, for example, n equals to 0. Okay, 0 plus 2 divided by 2, we will get 1. So the pair of x0 will be x1. Okay, the same for x3 and x4. Alright, so this is the figure of DIF butterfly. So we can see here the weight is at the right side, the lower right side. So next is you put the arrow at the lower side of butterfly here. Okay, for all these 4 shape of butterfly. Okay, next step is to calculate the weight. Okay, as I mentioned previously, for the weight we need to calculate the value of P, Q and T. Okay, and then you also need to calculate the WT. Okay, you can see this table, it refers to the weight label. Okay, so we have for the first stage we have W0 and W1. So here we just label W0 and W1. As for the second stage, we only have W0. So for both butterfly, we will have W0. Okay. So how to calculate the value of the weight? Here, you can refer to the previous video. Okay. So the next step is to fill in the given information. Okay. So for example, find the DFT of discrete signal xn equals to 1, 2, 1, 0. Okay, so you need to arrange the value of discrete signal in this area, where the left side is the discrete signal. So x0, our x0 is 1. It is at the location here, and then x1 is equal to 2. Okay, and then x2 is equal to 1, and lastly x3 equals to 0. So this is the location of the discrete signal. If our question give you the DFT value, so you need to arrange the signal at the right side. Okay, next is we need to calculate the value of each butterfly. Okay, so for the n equals to 4, we will have 4 butterfly. Alright, so this is the first butterfly, or the first pair of X shape. Okay, so this point we have 1, and the second point we have x2 equals to 1. So we need to calculate the value of E1 and G1. The operation between these two variable will be, at the upper side is plus. X going to the center, the operation is plus, and Y going to the center, so X plus Y going to the ups here, so X plus Y. As for this part, we have X going to the center, the operation for the lower part is minus, X minus Y going to the center, X minus Y, and then both X minus Y will be multiplied with WT. So we will get this equation. Okay, so to find the E1, okay, you need to double first E1, F1, G1, H1, I1, J1, K1 and L1. So actually for the label you can name it any variable. Okay, so we can calculate. First we need to calculate the E1. E1 equals to, from this equation, 1 X plus Y. So 1 plus 1 equals to 2. Next is to calculate the G1. G1 is 1 minus 1 multiply with the weight W0, which is 1. 1 minus 1 is equal to 0. So E1 is equal to 2 and G1 equals to 0. So we will give the value here, E1 2, G1 equals to 0. Next is we need to calculate the value of F1 and H1 from the second butterfly, or from the second X sign here. So first we need to put the first point, x1 equals to 2, the second point x3 equals to 0, and then we can calculate F1 and H1. To calculate F1, x plus y, or x1 plus x3 equals to 2. To calculate H1, we have x minus y multiply with Wt. So 2 minus 0 multiply with W1 is equal to negative j. So we will get negative j2. So next is you put the value of F1 and H1. 2 and negative j2. Next is at the stage 2. For the third butterfly, the first point we have E1 equals to 2. The second point we have F1 equals to 2. So to calculate I1, so I1 x plus y, or E1 plus F1, we will get 4. To calculate the J1, we have x minus y multiplied with Wt. So 2 minus 2 multiplied with W0 is 1. We will get 0. So the value of I1 here is equals to 4. J1 equals to 0. Okay, lastly, the fourth butterfly, we have the first point G1 and then the second point is H1. So G1 equals to 0, H1 equals to negative 2j. To calculate K1, G1 plus H1 equals to negative j2. And then to calculate L1, we have x minus y multiplied with Wt. So 0 minus negative 2j times W0 is equal to 1. So we will get positive j2. So next you will put the value of the calculated value here. So x DFT1 equals to negative j2, x DFT3 equals to positive j2. Okay, and finally you arrange the value of x DFT. So from x DFT0 we will have 4 and then negative j2, 0 followed by j2. So this is the answer of x DFTK by using the fast Fourier transform.